Okay, so for our next section, we're going to be talking about network programmability, or SDN, which is what I'm going to refer to it as. And as we jump into this, the first section that we see outlined on the blueprint is functional elements of this, as well as how they interact. So again, basically what we're talking about, just like in other topics we've discussed, that for these various blueprints, they're looking for, again, product awareness, right? Functional elements. What are the pieces? What are the moving parts? And what is it they use to communicate with each other? So that's going to be our first section here. Okay, so what is SDN? What is the whole thing? So we said it's software-defined networking. The biggest thing to remember about this whole thing is SDN is an overall solution to a problem. It's not a particular product. There's a lot of pieces that go together for this, okay? So the idea is to move the intelligence of the network, in other words, routing protocols and all this kind of stuff, to a central device. In the traditional IT and in the traditional networking model, routers, switches, which are basically operating as routers, so multi-layer switches, they all made their own decisions, right? All routing decisions were local on each router. So, let's say I have two paths on my network and I decide to send, this router decides to send the traffic across path A and it gets to the router on the other end of that. Well, that other router might make a completely different decision than what I did. In fact, one of the biggest risks with routing, of course, there's several, but one of the biggest is that other router that I just sent the traffic to, actually looking at the network a little differently than I am, says, well, you know what, I think that the best way to get there is right back through you again, and I don't understand why you didn't deliver it a different way. So, that other router sends the traffic right back to me, and of course this continues, I send it back to them, and we have a routing loop. Could be a small routing loop between two routers, could be a large routing loop, but what causes this? Couple things, right? Obviously, breakdowns and failures in routing protocols can cause this. And if we're talking about errors and things like that happen, this can happen in any environment, including SDN, right? I mean, if we're talking about bugs and errors and flaws, then of course it can happen in any case, all right? The bigger concern we're talking about is having a central point of intelligence, right, that has a picture of the whole network, okay? And if you're familiar with routing protocols, depending which track you're on, you may or may not be as up to speed on routing protocols, but this is sort of the idea behind OSPF, where all the routers exchange databases, they look at that database, and they all make a decision on how to deliver traffic based on that database. So it's sort of around this same idea that we're gonna make better decisions and more intelligent decisions if we have the big picture. If it's not every router for himself, good luck to you. Here are my routes. Hopefully you can make some sort of, decision on all of that, and hopefully we all end up delivering the traffic the same way in the end. Now, it's of course in most routing protocols not really hopefully, right? I mean, obviously, RIP, EIGRP, ISIS, OSPF, BGP, these all have built-in loop prevention mechanisms. Some are better than others. We're not going to get into that whole discussion. Okay, but they have loop prevention built in to try to prevent the routers from making, let's say, poor decisions. But the main point I'm trying to make here is routers making poor decisions about routing protocols and so on, this can all go away if there's one central device that can tell them exactly what to do because it has the big picture, right? Now, the first thing a lot of people think when they look at this is, oh my goodness, we're going to move everything to a central device. What if that central device fails? Well, yeah. So obviously some other discussions have to come up then, right? Redundancy. So this central device, which by the way, I'm just going to bring up the next section of this. This is of course called the controller. Okay, this is what the controller does. The controller is this central point. Now this could I'm starting to say it could just be a piece of software. It is a piece of software, okay? What I was going to say is that, it could be running in a virtual machine or it could be running actually on a router. It honestly doesn't really matter where it's running. at the end of the day. It is a piece of software. In the case of the Nexus 9Ks, they support this using a special software image, okay? And at the end of the day, that means that it's running on a, we'll call it a switch, right? Because the Nexus is a switching product, even though it's multi-layer, making it essentially a router. But nonetheless, without getting into that whole discussion, we'll just leave it that it's running on a physical piece of equipment, right? As opposed to virtualized in a data center somewhere, okay? But, it wouldn't surprise me if not too far down the road we start seeing that, okay? And there's other products that do it. I'm just talking about the Cisco product line. At the moment, we don't have that, except in like test environments. However, it wouldn't surprise me at all if we end up with a virtual machine appliance-based controller, because the actual controller itself is in fact running on a server in the Nexus environment. Okay, the APIC, which is the actual controller, is running on a server. Now, like I said, at the moment, they don't offer it as a separate product, right? So you've got a special version of code running on the 9Ks, and then you have the controller itself, which is running on, at this point, I believe it's a 1U C-Series server, I believe is the only offering at the moment. But again, things change. So, by the time you're listening to this, that might be a completely different model at this point. Because again, at the end of the day, the controller is nothing but a piece of software. It's a piece of software that, as you can see here on the slide, it does network monitoring. It's got to know what's going on. How can I make a decision if I don't know what's going on, right? It handles the configuration of the devices. Okay, like when you start getting into Cisco ACI on the 9000s, and of course, those of you going into the data center track are going to be talking a lot more about this. I'm just trying to give a quick overview. But Cisco's main product offering at the moment for this is ACI, with the APIC being the controller for that, and then ACI running on primarily the Nexus 9Ks. There is no configuration on those Nexus 9Ks then, okay? They're essentially plug and play. You plug them in, and the leaves find the spines and so on. Now, there's things you can go in and look at. There's always, show commands and debug commands, and there's stuff like that. But the controller is what's actually running the entire setup. Okay, that means it's also going to be in charge of the troubleshooting and, of course, fixing any problems. It handles software updates. Okay, and of course, all of the policy application. Okay, what devices should be able to talk to what other devices? And we could come up with some fancy networking terms for this, right? For example, Cisco ACI pretty much acts like a deny any firewall. It's more like a packet filter. We're not going to get into all that right now. But it controls what devices are allowed to talk to what devices and so on, okay? So again, the main thing here is that the SDN components are, of course, the specialized software for the network hardware. Like I said, in the case of the Nexus 9K, it is a special image that runs on the 9Ks designed to talk specifically to the controllers, to the APICs, which are running, again, on servers. That, of course, again, brings up the controllers, right? One or more pieces of software, usually installed on a server, or, again, just thinking out loud here that none of this is really has any basis on anything, but you could see it on a controller card. You could see it, they've put software all different places on Cisco products in the past. So, who knows where we're going to see this implemented in the future. But of course, right now there's the Cisco APIC, right? And we have a couple other devices here, but it's a centralized point of view for network monitoring, right? Network device discovery, like I said, the idea is it's basically plug and play. You plug the controller into, one of the leaves find the spines find all the other leaves through the specialized software. They all know they're supposed to be looking for each other to create this fabric, okay? Now that does mean, and again, we're not going to get into all this, but it does mean there's some specific cabling rules, what has to be plugged into what and so on, these sorts of things. But the point is, at the end of the day, that each device is not individually configured. Each device is not individually controlled. Each device is not individually making its own decision, okay? But the other thing to keep in mind about the controllers is I mentioned about having redundancy. That's, of course, going to be an issue. Cisco ACI, in fact, yells at you if you're using less than 3 controllers. It actually wants 3 controllers in the environment, so that's redundancy for your redundancy. Now, you can, of course, run it with 1. Okay, there's no hard limit where it says, oh, that's it. You're not, no ACI for you. You don't have enough controllers. It doesn't do that because, what if 2 of them failed and you were down to running on just 1 left, right? But, there's no hard limit or anything, but it will yell at you if you have less than 3. What if all 3 fail? Well, the good news is, in most environments, and again, there's different variations of SDN and so on, Cisco's implementation at the moment, the devices themselves are still intelligent devices. So even though they're running special code, and even though they don't get configured directly locally and stuff like this, and even though they're talking to the controller for everything, once they're booted and configured and they've gotten their configuration from the controller, if they lose touch with the controller, they will continue to forward traffic. So we don't lose connectivity. Our whole network doesn't go down if we lose the controllers. Now, of course, we can't make moves, adds, changes, things like this. We're going to lose a lot of our visibility into the network and so on, but we don't lose the entire network, okay? The last piece of this whole thing, and possibly, I think one of the biggest pieces they may test you on, which is why we're going to hit it on the next couple slides here, is the APIs. How do these devices all communicate with each other? And, of course, an API is just a generic term. We have it broken down here on the next slide with the definition here for you, right? It's just an application program interface. It's just a generic way of defining how 2 different programs, how 2 different applications talk to each other, right? And I will be the first to admit I am not a developer, so I'm not an expert on, APIs and all of this. But, basically, Windows has APIs, right? If you're writing a program and you need to find out what's 2 plus 2, you don't have to write a whole program just to be a calculator to add 2 plus 2, right? There are APIs that are exposed in the underlying operating system for, everything from, a built-in, obviously, calculator, random number generators, file manipulation, moving a file from here to here. If you write a program and you want it to be able to save or load a file, you don't have to write those routines. Those routines are built into the operating system. You just call to the API in the operating system to tell it to do that. So just generically speaking, an API is a way for 2 different programs or applications, 2 different pieces of code to talk to each other, okay? So what are we talking about here, right? So again, it's a pretty pivotal concept here because this is what we're using for the controllers to be able to talk to the network devices, and more importantly, well, maybe not more importantly, but equally importantly, right, is us to be able to talk to the controller. How do we tell the controller what our intentions are and what we want our network to do, right? That's the big thing here. Okay, so there you go, right? Defines how software components should interact with each other using protocols, routines, rules. And again, these could be industry standard, they could be, proprietary. That's a whole nother discussion, right? But we mentioned OpenStack in one of our other modules. So, some of these are free, some of these are proprietary. It's really just up to each individual vendor how they decide to implement all of this, okay? But again, it's just for one program to be able to talk to other programs, okay? In the case of SDN, we sort of define these under a term interfaces, okay? This is the communication channel between the 2 devices. Now, why is this important? Well, because like I mentioned earlier, there's one or more programs, but there's 2 different flavors here. There's the southbound interface, or the SBI, and the northbound interface, or the NBI. You might also hear these referred to as northbound APIs or southbound APIs. I've heard of both ways. I put the southbound interface and northbound interface here. Generally, in all my digging, it seems to be the more proper way to refer to it. But also in my digging, northbound API and southbound API seems to be the more common way to refer to it. So I'm not going to draw a differentiation there. Southbound interfaces are your southbound APIs, and these are, again, from the controller down to the actual equipment, okay? So this would be, in all honesty, the most common place that you would see maybe a proprietary protocol, right? Where, like for example, Cisco's API uses their own protocol here for this. Now that doesn't mean it's not necessarily compatible with OpenStack or other vendors' products. That's all, and I'm not going to get into that whole thing right now. Compatibility and there's limited support for various other products. They support this and not that, and so on. This is where you're going to run into the most compatibility issues, right? Because you're talking about having a controller from one vendor. Can it or can it not control equipment from another vendor? Okay. So this is where, they're still hashing out what are the open standards going to be, who's going to use the standards, and so on. We're going to get to that on the next slide with a couple other examples. Okay. The northbound interfaces are from, we'll say you, right, from the administrator. And the way we just, of course, put it generically on the slide here is SDN-aware applications. So, again, using Cisco as the example, since it is a Cisco course, when you start looking at the APIC, the controller unit, it has a built-in web interface that you can use for your initial configuration and setting the whole thing up. So you would make the argument that it's, a built-in SDN-aware application. It's a web interface, and of course it's making API calls using northbound protocols on the back end, okay? This is where you're going to see the most development happening, I think, as far as people making other products. This is where we can use things like Python and scripting, and we're going to get to this in the next section, but ways to automate this entire process. All of your automation and all that kind of stuff is going to be happening on the northbound protocols. Okay, this is where we as administrators do most of our work. Okay, so as far as, again, the southbound interfaces go, southbound protocols, there's a couple of them out there, right? I mentioned OpenFlow, which is part of OpenStack, NetConf. Some of these, I just pulled out of lists and such that I found. I'm not even sure if any vendors are actually using these or if they're proprietary to certain vendors. But these are just some examples that I came up with of what we're using to do the communication, okay? But again, the biggest thing to understand, this is not one of those places where I think for the written they're going to start listing them, okay? They're going to be a little more generic. What are southbound APIs versus northbound APIs? I think is the biggest takeaway here. The southbound APIs go from the controller down to the equipment, okay? Northbound APIs are, if you want to think about it this way, from the controller up to the administrator. So that's sort of where the northbound, southbound comes from, right? It's from the perspective of the controller. Southbound would be to the equipment. Northbound is to the administrator and the management software.